Imagine, imagine building this stunning multi-million-dollar model home.
Right, I'm picturing it.
You get the buyer to tour the property. They're looking around. They admire the gorgeous layout, the perfect ambient lighting.
Oh, yeah, really selling the dream.
Exactly. And they immediately sign the purchase papers right there on the pristine kitchen island. But then the general contractor turns to you and says, excellent. Now we just have to completely rip out all this beautiful drywall so we can install the actual plumbing and the electrical wiring.
Oh, man.
Right. The house looked totally finished, but the infrastructure was entirely fake. I mean, you open the refrigerator to put your groceries away, and you realize it is literally just a hollow cardboard box.
That is just, wow, what a perfect analogy for what we're talking about today.
It really is, because that exact scenario is what data analytics teams experience like every single day.
So welcome to deep dive number 26 of Data Design with Mokkup.
Glad to be here for this one. It's a huge topic. It really is. Today, we are analyzing the raw mechanics of streamlining dashboard wireframing and development, and we're specifically focusing on Mokkup's semantic layer export.
Because right now, the industry statistics reveal this just, well, massive inefficiency in how we work.
Yeah, studies actually show that a staggering 80% of analytics teams spend a huge chunk of their time on preparation, maintenance, structuring, basically anything other than actual analysis.
Which is wild. You know, you are hired to find critical business insights for your company, but you end up spending 80% of your time essentially doing digital plumbing.
Exactly, doing the plumbing.
And that is just a profound misallocation of highly specialized talent. I mean, Tableau themselves have pointed out that data preparation remains one of the absolute biggest bottlenecks in the entire analytics workflow.
So it's not just a minor annoyance, it's a real structural issue.
Oh, absolutely.
Yeah.
The disconnect between the design phase and the actual development phase, it is a fundamental structural flaw in how we build business intelligence tools today.
Right.
And that 80% statistic, that illustrates exactly why this matters to you, the listener. Because you are losing hours, days, sometimes, entire sprint cycles to repetitive configuration that really should be resolved long before development even starts.
Yeah, so if analytics teams are wasting that much time on prep work, we need to, examine the exact mechanism of that failure.
We need to look under the hood.
Exactly. We need to look at the raw mechanics of that disconnect between design and deployment, specifically what we're calling the layer cake problem of traditional wireframe exports. Because historically, wireframing tools have basically just handed us that cardboard refrigerator.
They absolutely have. I mean, for the last several years, if you used a wireframing tool, even, Mokkup's own earlier iterations, you could export a layout directly into a Tableau file.
And visually, it looked pretty good, right?
It did a highly respectable job visually. The layout was completely intact, the chart structures were correctly placed on the grid, and it was populated with all this nice mock data.
So your reviewers and your stakeholders could see something realistic on their screens.
Right. It secured the necessary approvals, which is great.
But the moment a developer actually takes that file and tries to connect it to the company's real live SQL database or even a live Excel feed, everything just breaks down.
Total collapse.
It's like the traditional export is really just an illusion of a finished product.
That is exactly what happens. And to understand why it breaks, we kind of have to look at what a Tableau file actually is.
Right, what's actually in there.
Yeah, because when you export a traditional .twbx file, you aren't exporting magic. A .twbx file is essentially just a zipped archive.
Okay, so it's a zip file.
Exactly. And if you unzip it, inside you will find .twb file, which is purely an XML document. It's just a massive text file full of code tags dictating exactly where every visual element sits and exactly which mock data field it's supposed to read from.
So when a developer opens that traditional export and tries to wire it up to live company data, that XML mapping
It completely shatters.
Wow. Because they aren't just swapping out a single data source, right?
Right. They are forcing the XML to look for column names that suddenly do not exist anymore in the new data.
Oh, I see.
Yeah.
So the layer cake literally crumbles, and the developer basically has to rebuild the entire dashboard logic from scratch.
Yep. Which means the tedious work is really just beginning. Because every single chart type handles that XML mapping differently. It is definitely not a universal fix where you just, hit a refresh button and the live data perfectly replaces the mock data.
Right, that would be too easy.
Way too easy. Let's actually look at the raw mechanics of just a simple axis-based chart to see why this eats up so much time.
Okay, like a standard bar chart.
Yeah, standard line chart, bar chart, whatever. The XML in that traditional export is hard-coded to a mock dimension. Say it's called a mock underscore category A, and a mock measure, like mock underscore sales value. Well, when you connect your live data, you, as the developer, have to manually go into the rows and columns shelves in Tableau and painstakingly swap out those broken mock fields for the real dimensions and measures.
So you're in there manually rewriting the mapping for every single visualization.
Every single one.
Which, I mean, that might be manageable for 1 or 2 charts,
Yeah.
but enterprise dashboards often have 20 or 30 different visual components.
Exactly.
And that's just for basic bar charts.
Yeah.
How does this structural failure impact the more complex visualizations?
Oh, it becomes exponentially more difficult. Take histograms, for example.
Oh, right, because of the bins.
Exactly. A histogram relies on binning logic. You're grouping data into ranges based on the distribution of the numbers. Well, the mock bins generated by a traditional wireframe export are totally useless once your underlying live numbers change.
Because the distribution of your actual sales data is going to be entirely different from the fake mock data.
Right, so you literally have to discard the old bins and create entirely new ones from scratch.
Ugh, what a nightmare. And what about Sankey charts? Whenever I talk to BI developers, they universally mention Sankey charts as being like the most fragile visualizations to maintain when data sources shift.
Oh yeah, Sankey charts are notoriously difficult because of how they actually render. They don't just plot a simple number on a y-axis.
Right.
They rely on very specific coordinate mapping of nodes to draw those flowing paths between the categories.
So in a traditional export, the moment the data shape changes, say your live data has, I don't know, 5 categories instead of the mock data's 3, what happens?
The rendering engine completely loses the coordinate mapping of those nodes. The flow paths break entirely.
Oh, wow.
Yeah, so the developer is forced to basically remove all the fields, rebuild all the complex data scaffolding, and re-add everything just to get the diagram to even render correctly again.
We haven't even touched on the advanced metrics like waterfall charts, gauge charts, or KPI cards. You can't simply drag and drop a live field into those components.
Not at all. They require very specific underlying math.
Right.
So to display a simple year-over-year growth percentage on a KPI card, you need freshly calculated metrics. A static wireframe export doesn't contain that calculation logic.
It's just a text box, basically.
Exactly. It just contains a static text box that says, like, plus 15%.
So you are literally starting from a half-built foundation, cross-referencing a static PDF or an image of the design document, and trying to write the calculation logic from memory.
It's so tedious. And when data models, calculated fields, and metric definitions aren't locked in and standardized from the absolute beginning, developers are forced to spend countless hours just validating that logic.
Oh, I bet. They probably have to pause their work constantly.
Constantly, they have to stop and go ask stakeholders, wait, does this sales KPI in your design include regional taxes? Or is it strictly net sales?
They end up having to act as business analysts mid-implementation.
Right, they're rebuilding parts of the dashboard on the fly to match logic that was never actually defined in the first place.
Which injects so much unnecessary manual effort into almost every single step of the workflow. The old method functioned eventually, but it was incredibly inefficient.
Highly inefficient, yeah.
So if the traditional export forces us to, tear down the drywall to install the plumbing, the core question becomes, how do we bake the plumbing directly into the initial blueprint?
Right.
How do we build the house with the pipes already in the walls?
Well, that brings us to the methodology Mokkup has implemented to solve this. It basically operates as a two-part system.
Okay, let's hear it.
The first component is their Convo.ai, and the second, which really solidifies the entire process, is the semantic layer.
So let's start with Convo.ai because the mechanism behind it seems to completely bypass the whole blank canvas problem.
It really does. It's like having a front door to the whole process.
Yeah, you can essentially describe the dashboard you want in plain language. So for example, you might type a prompt like, I need a sales performance dashboard with a geographic heat map, a year-over-year revenue KPI, and a waterfall chart for profit margin.
Right.
And then you upload a data file, and instead of just giving you some generic template, Convo.ai reads the headers of that specific file and builds the wireframe around them.
And the mechanism of how it actually reads those headers is what makes it highly effective.
How so?
Well, it uses natural language processing, or NLP. So it doesn't just read the text. It infers relationships based on standard data architectures.
Ah, okay. So if Convo.ai sees a column labeled transaction date and another labeled revenue, it doesn't just see random words.
Exactly.
It recognizes a time series relationship there and automatically generates a line chart over time, rather than just guessing what chart type you might want.
Spot on. It creates a completely bespoke layout based on your actual business vocabulary and the inherent structure of your own data.
Yeah, it's really cool.
It is. The spatial layout is optimized for the data you actually possess, rather than forcing your data into some generic placeholder grid. But the true innovation, the part that really solves our drywall problem, is the second component.
The semantic layer.
Yes.
Now, whenever I hear the term semantic layer in data architecture, I usually think of a translation engine.
Okay.
Like it usually sits between the raw database tables and the business logic, translating raw numbers into understandable business metrics. Is that similar to what is happening here during this export process?
That is an incredibly accurate deduction, actually. In this context, the semantic layer acts as a sort of universal translator that also possesses structural memory.
Oh, I like that. Structural memory.
Right. So when you use Mokkup to export that AI-generated wireframe into Tableau, the semantic layer takes that exact data file you uploaded and it writes all the necessary XML tags in the background.
Wait, really?
Really, it bakes the datasets, the measures, and the specific formulas directly into the .twbx file before you even open it.
So it is actively writing the calculation syntax into the background code.
Exactly.
It completely transitions from being just a superficial visual layout into a fully functioning analytical model.
Yeah.
The pipes are officially in the walls.
Precisely. It generates a customized Tableau template where the calculated fields, the dimensional mapping, and the dataset are already structurally bound together.
Okay, I need to pause here, though, because I have to push back a little on the security implications of this process.
Okay, let's hear it.
Because if I am a developer working for a major financial institution or, perhaps a healthcare provider governed by strict privacy laws like ATPFA,
Sure.
and I hear that I need to upload my company's live data file into an AI tool just to generate a wireframe, my compliance officer is going to shut that down immediately.
Oh, 100%.
Right. Aren't we exposing highly sensitive rows of business data to some external AI model?
That is a very valid concern, and it's a critical point of friction for enterprise adoption. But the distinction between row-level data and metadata is exactly how Mokkup handles this securely.
Okay, metadata. Walk me through that.
So when you upload a file, the AI and the semantic layer only read the metadata.
And by metadata, you mean strictly the architecture of the file, not the contents.
Correct. Metadata includes the column headers, the data type, so, whether a specific field is a string of text, a chronological date, or a numerical integer, and any basic formulas defined in the schema.
Okay, so it sees the labels.
Yes. The underlying rows of data, the actual names of your clients, the individual transaction amounts, the private patient records, those are never accessed, they are never read, and never stored by the AI.
Oh, wow. Okay.
Your sensitive data stays entirely secure within your own network because the system is really only looking at the blueprints of the house, not the people living inside it.
Got it. Okay, well, that distinction changes the entire risk profile. You are uploading the structure, not the substance. And because the semantic layer knows that precise structure, it can pre-build the corresponding logic. So what exactly comes pre-built and configured when I finally hit that export button?
Concretely, the Mokkup semantic layer writes 3 major infrastructural components into every single export.
Okay, step me through them.
First, all the required metrics and measures are defined and named perfectly to match the exact vocabulary of your data file.
Nice.
Second, the uploaded sample dataset itself is attached to the workbook as the active data source, so the XML mapping is already completely live.
It's already talking to the data.
Yep. And third, and this is really where developers save the absolute most time, all calculated fields and formulas are already written and configured.
Wait, meaning if the wireframe includes a year-over-year growth KPI, the developer does not need to manually write that calculation syntax in Tableau.
They do not?
No way.
I'm serious. The YOY growth measure, the specific mathematical formula driving a gauge chart, the complex step logic required for a waterfall chart. It is all already written into the code.
That is incredible.
It's mathematically ready to produce values the literal moment the workbook opens, assuming the data source is feeding it numbers.
That drastically shifts where a developer spends their hours. Let's examine how this actually looks in practice for the listener. Let's walk through the precise 4-step workflow.
Let's do it.
If the logic is baked into the metadata, What happens on a Tuesday afternoon when a developer actually tries to use this tool and connect it to their company's live database?
Okay, so step one is the upload and schema matching phase.
Right.
As you start designing the wireframe, you feed a data set into Convo AI. The absolute best practice here is to use a lightweight sample dataset that perfectly mirrors the schema of your real production source.
Because of the metadata rules we just discussed, you do not need to pull a billion-row production database into the wireframing tool.
Please don't.
Yeah, you just need a 10-row CSV file, right? As long as it has the exact same column headers and data types as the massive SQL database you'll eventually connect to.
Exactly. Schema consistency is the absolute key here. Matching the column names perfectly is what allows the semantic layer to interpret the file correctly and pre-write all those XML calculation tags accurately.
Got it. Okay, so once your design is finalized and the sample data has structured the logic, you move to step 2.
Which is the export phase.
Right, you click export and Mokkup packages everything into that zip.twbx archive, which contains the layout, the charts, every pre-written formula, and the sample data set.
Which leads directly into step 3, connect.
The moment of truth.
Exactly. The developer opens that .twbx file in Tableau Desktop. If the wireframe included complex visuals, Tableau might prompt the user to, approve a specific extension, which is totally standard procedure.
Sure.
And then the critical mechanical move occurs. The developer swaps the sample dataset for their real live production data source.
And because the sample metadata perfectly mirrored the live database schema, the XML mapping doesn't break.
Nope.
The plumbing connects flawlessly to the city water main.
Precisely. There is no manual replacing of dimensions on the rows and column shelves because the column names match perfectly.
And the Sankey chart.
The Sankey chart doesn't break because the coordinate mapping logic was preserved through the semantic layer.
That is so cool.
Yeah, the waterfall chart instantly recognizes the live data and just populates based on the pre-written formulas.
Which brings us to the final step, step 4. Verify and publish.
Right, the final check.
The developer performs a quick visual check. They ensure the visuals are rendering properly with the heavy production data. They can match the company's specific hex color codes, which, by the way, can be pulled straight from the Mokkup wireframe specs.
Super handy.
Yeah. And once the aesthetics are verified, they just publish the dashboard to Tableau Cloud or distribute it to the team.
Just think about the friction that has been completely removed from the traditional workflow here.
It's massive.
We bypassed replacing mock fields chart by chart. We eliminated the need to manually write and debug calculated fields. We removed the tedious process of reconfiguring KPI logic from scratch. And we bypassed hours of debugging visualization errors caused by broken data references.
But okay, let's talk about the reality of dashboard development. Because stakeholders inevitably change their minds.
Oh, always. It's guaranteed.
Right. A stakeholder will look at a near-finished dashboard and say, actually, can we view this entire layout by geographic region instead of by product category?
Yep, classic move.
In the traditional workflow, a mid-build change like that often meant ripping out the underlying logic and starting completely over, which totally jeopardizes tight reporting deadlines. How does this new architecture handle those kinds of late-stage pivots?
It handles them with significantly more agility. Because the foundation is inherently robust and intrinsically tied to the structural metadata, pivoting is just drastically faster.
Because the XML mapping is already clean.
Exactly. The calculations are already centralized. The fewer manual rebuild steps a developer has to juggle, the lower the chance of introducing inconsistencies or mathematical errors when they're rushing to accommodate a late-stage stakeholder request.
Now, I am curious about how this impacts the broader Power BI ecosystem, because we have been focusing super heavily on Tableau today.
Sure.
You mentioned earlier that this semantic layer is also live for Power BI. And Power BI has its own entirely distinct underlying architecture, specifically concerning DAX, right? Data analysis expressions.
Oh, DAX is a perfect example of why the semantic layer is so valuable. DAX is incredibly powerful for modeling complex relationships in Power BI, but it can be notoriously difficult to write and debug.
Why is that?
Primarily because it relies heavily on filter contexts and row contexts. Evaluating how a DAX measure behaves when different filters are applied across a dashboard, it requires deep technical expertise and a lot of trial and error.
So does the Mokkup semantic layer pre-write the DAX formulas in the same way it pre-writes the Tableau XML tags?
It applies the exact same structural philosophy, yeah. Instead of generating a .twbx file, Mokkup exports a .pbix file for Power BI.
Okay, the Power BI file format.
Right. The semantic layer analyzes the metadata and bakes the pre-wired measures and the DAX equivalent calculations directly into that .pbix file.
Wow.
Yeah, the DAX filter contexts are already mapped to the visual layout. Power BI teams receive the exact same head start. They open the file, connect the live data schema, and the DAX measures evaluate correctly without requiring the developer to write the syntax from scratch.
That fundamentally changes the resource allocation for an entire sprint. But, it does raise a question about the evolution of the analytics team itself.
Oh.
Yeah, if an AI tool and a semantic layer are doing all this heavy lifting of mapping the schemas, configuring the KPIs, and writing the underlying DAX or Tableau calculations, is the traditional business intelligence developer's role shrinking?
It is not shrinking, it is elevating.
Elevating.
Absolutely. Think about it. Developers do not want to spend their valuable hours writing the exact same standard year-over-year DAX calculation for the 100th time in their career.
True. It's monotonous plumbing.
Exactly. By automating that foundational configuration, the developer's focus shifts from tedious repetition to high-level architectural analysis.
They transition from being purely builders to being actual analysts.
Exactly. With the baseline plumbing installed automatically, they can dedicate their time to optimizing database query performance, building really complex deep dive drill down actions, or collaborating with stakeholders to find the actual business insights that the dashboard is supposed to reveal.
You're automating the boredom out of the job.
Yes, you're allowing highly skilled professionals to do what they were actually hired to do.
Which brings us to the core takeaway for you, the listener. We started this deep dive exploring that 80% statistic, that massive chunk of your week lost to preparation, maintenance, and rebuilding logic that was already approved during the design phase.
Such a waste of time.
It really is. By implementing a wireframing tool equipped with a semantic layer, you are literally erasing the friction between design and deployment. You are buying back hours, if not days, of a developer's life on every single project by ensuring the metadata schema writes the code for you.
It creates a remarkably smoother, mathematically sound path from a stakeholder's initial concept to a fully deployed business intelligence foundation.
It is a complete paradigm shift for how analytics teams operate. But, analyzing this shift leaves me with one final thought. Something for you to mull over as you head back to your own data architecture projects today.
Ooh, I love a good final thought.
Think back to our model home analogy. The old way of wireframing was building a beautiful house out of cardboard, securing approval from the buyer, and then tearing it down to build a real structure completely from scratch.
Yeah.
This semantic layer approach builds the real pikes into the walls from day one.
Right.
But if an AI can now accurately translate a plain language prompt into a visual wireframe, and a semantic layer can perfectly translate that visual wireframe into a fully functional, coded business intelligence foundation.
Yeah.
How long until the concept of a distinct wireframe disappears entirely?
Oh, wow.
Right. If designing the mockup is mechanically identical to building the final product, are we witnessing the end of the wireframe as a separate step in the analytics lifecycle?
That is a fascinating architectural frontier to consider as these tools evolve. I really wonder where it goes from here.
Me too. Definitely something to carefully consider next time you map out a dashboard. Thank you so much for joining us on this deep dive into data designed with Mokkup. We will catch you on the next one.